So in the last video, we pretty much got through step one of constructing the real numbers. We got two nice conceptual models for understanding what real numbers were intuitively. Now we're going to go on to step two, and that is looking to make some axioms for real numbers. So we want to make a complete list of axioms for real numbers. We are going to look at axioms for addition and multiplication, so that's the arithmetic part of it. We're going to find the axioms for the order relation less than. And then we're going to sort of ask ourselves, once we get to the end of that list, did we miss any axioms? And what does it even mean to miss an axiom? So here are some familiar properties from addition and multiplication that we would, of course, expect in the real numbers. We need addition and multiplication to be commutative. So that means for any real numbers a and b, a plus b equals b plus a, and a times b equals b times a. Addition and multiplication should also be associative, which means that when you add three numbers, a plus b plus c, that's the same as adding the numbers a plus b plus c, and similarly for multiplication. We have the distributive property, which means that a times the quantity b plus c is the same as ab plus ac. We have an additive identity, as we've noted before. There exists, we call it zero. That leaves everybody alone when you add it to it. So a plus 0 equals a for all real numbers a. We have an additive inverse for every real number. So anytime you have a real number a, there's some negative a, where when you add that to a, you get 0. And we go through the same thing more or less for the multiplicative identity and inverse. So we get a multiplicative identity, we call that 1. That leaves everybody alone when you multiply it by a number. Every non-zero number has a multiplicative inverse. So if a is non-zero, there is some number a inverse, where a times a inverse is equal to 1. And these are the axioms that are called the field axioms, so they make the real number a field. So if we move on to the order axioms, we're going to have actually the same axioms that we saw when we were constructing the integers. So this isn't going to be anything new, but it's good to list them anyway. So we have what's called trichotomy, which means that anytime you have two real numbers, either the first one is less than the second one is less than the first one, or they happen to be the same number. Those are the only three possibilities. We have transitivity that allows us to put them in order. So if a is less than b and b is less than c, then a is less than c. We have translation invariance, which says when you have an inequality a is less than b, you can add the same number c to both sides and keep that inequality. So if you add c to both sides, you get a plus c is less than b plus c. And then you have something very similar to that for multiplication, except it only works when you multiply by a positive number. So if you have a less than b, if you multiply both sides by the positive number c, you get ac less than bc. So if you take all the field axioms from the previous slide and combine them with all the order axioms, you get what's called an ordered field. So the set of real numbers is an ordered field. So you may notice some properties missing. For instance, what happens when you multiply by a negative number? You may remember back from your algebra days that when you multiply by a negative number, it still works, but you got to flip the inequality. But it turns out that we don't need to include those in the axioms because those can be proved from other properties. Remember, we don't want any redundancy in the axioms. We want to make the list as short as possible. So we actually have one more axiom. It's kind of implied, but we need to state it explicitly just to be safe. And that is the real numbers have to contain the rational numbers, right? I mean, we knew that, but we've got to state it explicitly just so we make sure we include it in the list of axioms. Now, I said one more axiom. I should have said at least one more axiom because we don't know if we're finished, right? Question is, are there any other axioms? And you might ask, what does that even mean? Are there any other axioms? Well, we need to make sure we have enough axioms that we can distinguish the real numbers from other number systems, right? So the question I'm asking here is, do the axioms that we have distinguish R from the other number systems that we know? And, well, the short answer is no, because in fact, the rational numbers also satisfy all the above axioms, right? The rational numbers are an ordered field, just like the real numbers are. So the ordered field axioms aren't enough to distinguish the real numbers from the rational numbers. And we know the real numbers are different from the rational numbers. We spent all those activities back from the last set of activities proving that we had a whole bunch of irrational numbers. So we need one more. We need at least one more axiom, and it turns out one more axiom is enough to distinguish the real numbers from the rational numbers. And I know you're just dying to know what it is, but we're not going to get to that until section 1.6. So that's a few videos and sets of activities in the future. Sorry to delay that for you, but we will get there to that axiom. We have some background to go through before we actually get to that. All right, so now is a good time for you to work on the set of activities. There's a link below this video. It's for ordered fields, and we'll work on those in class.